Good day, grade 12s. I hope you are fantastic. Welcome back to another exam revision lesson with Mr. T. And as always, I'll be sharing my approach to grade 12 maths, and I really hope that this lesson will be relatable and beneficial to you. Okay, so before we start with the lesson, please don't forget to subscribe and to also like the video. Okay, so in today's lesson, we're going to be looking at the November 2022 DBE mathematics exam, particularly question 8. Okay, so let's begin. So, as we usually do, we firstly start with the details of the question, the information, and then we get into the questions. All right, so we simply just going to do that. So it reads as follows. The graphs of y, or the graph of y, is equal to f prime x, okay, which is equal to mx squared plus nx plus k, and that graph is drawn below. Okay, the graph passes through the points p, q, and r. Okay, so point p is -1/3 or -3rd, and it's plotted over there. Then the q is plotted over here, that's 1 and 0. The y is plotted up there, right? So p and q are your x-intercepts, okay? That's why you see them on the x-axis. That's where the graph intersects with what? With the x-axis. And then the r is on the y-axis. That's where the graph intersects the y-axis, okay? So now, let's read again, but this time we're going to read to understand. So it says the graphs of y, or the graph of y, is equal to f prime x. So what does that mean? It means that this particular graph is the first derivative of a cubic function called f of x. Okay, we don't know the formula of the f of x, but we know for sure that this here, what we are looking at, is the first derivative of a particular cubic graph. Okay, then they said the formula therefore of this first derivative is mx squared plus nx plus k. Okay, and this graph is drawn below. The graph passes through the points p, q, and r. Okay, so as we know, the first derivative of a cubic function is a parabolic graph. Okay, it's a quadratic equation, therefore that suggests that it's a parabolic function. Okay, and the second derivative of a cubic is a linear function. Okay, it's a linear equation which then suggests a straight line graph. Okay, so in this case, what they've done is they've used the first derivative of a cubic to draw this parabolic function. Okay, now there are various things that you need to know if you don't know already. So the x-intercepts, the x-coordinates of the x-intercepts of the first derivative of this function that we are looking at here, right, are the x-coordinates of the turning points of the mother graph, which is the cubic. Okay, so if they had to ask you for the x-coordinates of the turning points of the cubic function, you would say, oh, the x-coordinates would be -1 and 3, -1/3. You wouldn't know the y values, and 1 and question mark. Okay, so the x-intercepts of the first derivative are the x-coordinates of the turning points of the mother graph, which is the cubic. Okay, I hope that makes sense. If I perhaps I should explain it from a different perspective. You probably already know this. When you calculate the coordinates or the x-coordinates of the turning points of a cubic function, what do? You do the first derivative, then you equate the first derivative to 0, then you solve for x, right? Now remember, the first derivative of a cubic is a quadratic, right? Then you equate that quadratic to what? To 0, then you work out the values of x. Now, here's a question or something to think about. when you calculate the x-intercepts of a quadratic function, of a parabolic function, what do? You do the same procedure that you do with the turning points. You just take the quadratic, you equate it to 0, because we say the y-coordinate of any x-intercept is 0. You equate it to 0, then you solve for x. Okay, so you pretty much do the same thing to calculate the turning points, or the x values of the turning points, and to calculate your x-intercepts of the parabola. I hope that is crystal clear. Okay, now let's proceed going to the question. The question says determine the values of m, n, and k. Okay, so they've given us that this particular function y is equal to f prime x, which is equal to mx squared plus nx plus k, right? And as we know, according to the parabola, the constant in the equation is always the y is always equal to the y-intercept. What's the constant? The constant would be the k, right? So that's going to be equal to the y-intercept. So it's going to be equal to this, to the value, the y value of the y-intercept. So then we're going to come here, say y is equal to 1. Always the constant in your formula is equal to the y value of the y-intercept. Okay, and then from there we can substitute everything here. Say f prime x equals to, it's going to be mx squared plus nx plus 1, right? Let me just quickly check something. Okay, plus 1. Then from here we're gonna have to then work out our values for m and n, right? So how do we do that? Simple. Remember what I said in one of the previous videos. I said to you that whenever you're dealing with two variables, right? Whenever you're dealing with two variables, it always requires, or it suggests, that you should apply simultaneous. Okay, now how do I know that we are dealing with two variables? It's because this is the first derivative of a cubic, right? It's the first derivative of a cubic, meaning that I can substitute these x values, a third and 1, right? And then make the subject, which is the f prime x, equal to 0, right? So there's two ways you can look at this. You can look at it from the cubic side of it, or perspective, and say, okay, so the negative third and the 1 are the x values of the turning points, right? Now, in the first derivative, right, if we were to substitute the coordinates of the turning points, what would the f prime x be? What would the gradient be? The gradient would be 0, because at the turning points of the cubic, our gradients are 0. Okay, so it means that if I had to substitute 1 over 3, right, into this equation in place of x, my f prime x would be equal to 0, right? Correctly so. Why? Because the negative 1 over 3, like I explained previously, is the x coordinate of one of the turning points in the cubic. Okay, now usually we work this, you can say going forward, but this time around we're working it backwards. Okay, so we usually just get the cubic, derive it, equate it to 0, solve for the x values of the turning points. This time around we are given the x values of the turning points. Okay, so we have to reverse the process. Okay, so now we're going to take the 1 over 3, substitute it here, and then make the f prime x equal to 0. Then we're going to call that our equation 1. I'm not writing at the moment because I want to also share a different perspective. So then we're also going to do the same thing, but while we're still on this, I just want to emphasize this. Okay, and please do pay attention to this. Okay, in maths, you have to be very flexible, okay, in the sense that you should be able to work something forward and also to reverse it. Okay, if you cram how to work out things going forward and you don't learn by yourself to reverse it, you're going to struggle a lot. And by that, I'm not downplaying it. I mean, you are really going to struggle. Okay? So the minute you learn to reverse things, that's when you start to build your strengths. Okay? Why? Because not all questions will be straightforward. Not all questions will require you to just derive from a cubic function or cubic equation to the first derivative to the second derivative. Sometimes you might have to start from the second derivative and work your way up from second derivative to first to the original. Okay? So please do take note of that and take it very seriously. If you really want to get a distinction in maths, excel, be top of your class, these tips are gonna really help you. Okay, so as I was saying, we substitute the negative 1 over 3 then into this, then we make our f prime x be equal to 0 because it's the gradient at the turning point. Then we call that equation 1. To derive our equation 2, we're going to use the 1. We're going to use this guy here. Take the y, 1, substitute it in place of x over here, then make the f prime x equal to 0 as well. Do you understand? I hope that makes perfect sense. That's how you're going to derive your equation 2. But now, looking at it from a different perspective. Remember, the first perspective was looking at it from a cubic perspective. This time around, we're going to look at it from a parabolic perspective, right? Remember, they said the f prime x is equal to y. Right? Meaning we can ignore this and use the y to find our m, n, and k. Right? So what we would do is we would then say, okay, to use the parabola, we'll say, okay, we already have the value of k. Right? For us to calculate the m and the n, we can just substitute the coordinates of the x-intercepts. So we substitute this to form our equation 1, because this is going to eliminate both the y and the x. So let me just write it here, y equals to mx. If you look at it from this perspective, right, the y will go over there, the 0, and then the 1 over 3 will replace all the x's there. Same thing goes for q. So then with those 2 points, you can form your equation 1 and equation 2. Okay? But ultimately, the solution will look the same because you are replacing this side with 0. You are replacing this side here. You're replacing this side with 0. Okay? So since we're dealing with the cubic, I would recommend that you use the first perspective so that you can also expand your understanding on cubic functions. Okay? So we're going to say we have the x coordinates of the turning point. It's the negative third and the 1. And then we know that at the turning point, our f prime x, the gradient is 0. So we're going to form our first equation. Say 0 equals to m open bracket negative 1 over 3 squared plus n open bracket negative 1 over 3 plus 1. This is going to give us positive 1 over 9 m plus, not plus, but minus 1 over 3n plus 1. That's equal to 0. We then call this equation 1. Okay? To formulate our equation 2, we are then going to say 0 again equals to m in the bracket. We put 1 squared plus n1 plus 1. This will then give us m plus n plus 1 equals to 0. Okay? Then from here you can make m or n subject of the formula in your equation 2. Okay, so we're going to say, let me use green. Going to say, let's make m subject of the formula. I'm going to say, take these two to the other side. Negative n minus 1 equals to m. Call this equation 3. Now, as if you look at the memo, your 2022 exam memo, they didn't use the substitution method, but they used simultaneous. Okay, now if you've noticed with all my lessons, everywhere where I'm required to use simultaneous, I always use the substitution method. Why do I do so? It's because I'm trying to show you that the substitution method applies in every case that requires simultaneous. Okay, there is no case that is excluded. There's no question of simultaneous that only uses elimination. Okay, every simultaneous has two options. You can either go with elimination or you can go with the substitution. All right, I always opt for substitution because I find it a lot easier and it's more systematic than elimination. I feel I could be wrong. Maybe the elimination method is more appealing to you, but as for me and how I prefer to work things out, the substitution is much more appealing. Okay, so I'm also trying to build the consistency so that you see that, okay, you can apply it in everything, okay, in every simultaneous question. Okay, I hope that this is going to help you also to be a bit more confident when you use it. All right, so we now have three equations. We have equation 1, equation 2, equation 3. Right? So what do we do then from here? We have to then substitute equation 3 into equation 1. Okay? Why do we do so? We do so because equation 3 comes from equation 2. So we can't substitute it back into equation 2. We're going to have 0 equals to 0. Okay? It won't work. So now, I don't have enough space, so I will just have to erase this here. So we're going to substitute this. Let's use a different color. I'm going to use black now. So 0 equals to our m, we said is what? It's going to be 1 over 9 here. Our m is negative n minus 1 close bracket. And then we're going to have minus 1 over 3n plus 1. Okay. Okay, now I can erase all of this because I'm going to need all this space here. All right. So let's simplify everything. We're going to have 1 over minus 1 over 9 n minus 1 over 9 minus 1 over 3 n plus 1, right? Then you take your calculator, you add everything up. You're going to have 1 over 3 added with 1 over 9 gives you negative 4 over 9. And then you're going to have 1 over 9. You add that with, say, plus 1. It's going to give you, no, you have to subtract them. The 1 over 9 is a negative. Okay. There we go. It gives you plus 8 over 9, right? Okay, I hope I got everything right. Let me just check and confirm everything. So when you multiply in there, you get this. There we go. Perfect, perfect, perfect. Then you add these two. They give you negative 4 over 9. Subtract those two, give you 8 over 9. All right, then you transpose the 8 over 9 to the other side. It's going to give you negative 4 over 9n. And then from here, you can just multiply. Obviously, the 9s will drop. The 9s just drop. Then you're left with 8 equals to negative 4n. Divide both sides by negative 4. This cancels that. N equals to negative 2. Okay, I hope that makes perfect sense. If this method is a bit confusing with the 9 there, you can always do this. Divide both sides by negative 4 over 9. Negative 4 over 9. This will cancel that. Then your n will then be negative 2. Okay, so we now have the value of n. We just have to calculate the value of m. We're going to come here and say, okay, our n is negative 2 minus 1. That's our m over there. Then, hold on, no. Okay, I realized that I made a mistake here. When I transposed the 8 over 9 to the other side, I didn't make it a negative. Okay, so it's going to be negative. Then you divide both sides by negative 4 over 9. Negative 4 over 9. This cancels that. N equals to 2. Then you come over here. Substitute. You're going to have negative open bracket 2 minus 1 equals to m. This will then give you negative 2 minus negative 1, which then your m will be negative 3. There we go. Okay. I hope that makes perfect sense. Now, here's another thing. Learners often think that as tutors, and I'm glad that I made that mistake, that as tutors, and I'm not going to edit this part out because I want you guys to realize what I'm about to say. Learners often think that, even with my learners, often think that we don't make mistakes. Okay, it's like, oh man, you have everything figured out. It's amazing how you can work out this question paper in like, it's supposed to be 3 hours, but you can work it out in like 1 hour, 30 minutes, half the time. But it doesn't mean that we don't make mistakes. Okay. Yes, we've been probably teaching this for a very long time, so we know the work in and out, right? But we still make mistakes. And I'm saying this because I want you guys to realize this. It's okay to make mistakes, all right? But when you make mistakes, do exactly what I did now. Don't work out something and convince yourself that it's correct and you don't go back to check it. Do you understand? So as you're working your work out or the questions out, you have to also think, okay, did I make any mistake? Let me maybe go back and check. Do you understand? Which is exactly what I did here. I looked at that. I'm like, okay, I think I might have made a mistake. I went back to check, did I do anything wrong? And, there it was. I realized that I transposed the 8 over 9 to the other side, but I didn't make it a negative. Okay? So being a teacher or a tutor doesn't mean that you don't make mistakes. You do make mistakes, but you should be able to admit when you've made mistakes. Okay? With some teachers or some tutors, they make mistakes and they just move on. It's like if you've made a mistake, it suggests that you're not a good teacher or you're not a good tutor. This is life. We all make mistakes. And for you learners, I hope that, things like this, I know it's not only me that will admit when they've made a mistake, but you can learn from us, and be like, okay, if sir can make a mistake, I can also make mistakes. But I have to be able, consciously so, go back, revise my work, see where I might have gone wrong. Okay? So now we have calculated our M, and we've calculated our N, and we've calculated the K. Oh, actually we're done. So our M is going to be negative 3. Our N is going to be 2. Our K is going to be 1. There we go. Okay? So I hope that you understood everything we did here. And yeah, let's go to the next question. Okay? The next question says, if it is further given that f of x is equal to negative x cubed plus x squared plus x plus 2, determine the coordinates of the turning point of f. Okay? Determine the coordinates of the turning point of f. I think in the previous question, I emphasized this a lot, that to calculate the x coordinates of the turning point, or turning points, because this one is two turning points, you have to find the first derivative first. Okay, so let's quickly do that. We're going to say f prime equals to negative x, it's going to be negative 3x squared plus 2x plus 1, which is basically the equation we got previously in the previous question. So then from here, you just equate this to 0. It's going to give you negative 3x squared plus 2x plus 1. Then you say equals to, open your two brackets, 3x, then you get your x. Obviously this has to be 1, 1, and it has to be plus plus. Then we just have to figure out between the 3x and the x, which one should be a negative, right? So it's going to be this one here, right? Then we're going to have 3x equals to -1 or x equals to -1. Then negative x equals to -1. We divide both sides by -1. That cancels that. X equals to +1. This side, we're going to have 3x is equal to -1/3. Okay? Then, we have our x values. We just have to calculate the y values. I'm just going to calculate them down here. I don't have enough space. I'm going to calculate them down here. So I'm going to say f of -1/3 equals to, then I'm going to say negative open bracket 1/3 cubed plus -1/3 squared plus -1/3 plus 2. Then we put that in your calculator. 1/3 plus squared plus -1/3. Right, excuse me, I'm still punching this in the calculator. Let me see if I put everything correctly. Again, see, I put everything in the calculator, but I'm now checking if I put everything correctly, and there is a mistake. Let's see. Put a minus there. There we go. Then we get 49/27, right? Then we do f1. It's going to be -1 cubed plus 1 squared plus 1 plus 2. This is going to give us -1 plus 1, that's 0. 1 plus 2, it's going to give us 3. There we go. So the coordinates will be -1/3 and 49/27. Then on the other side, you can have 1 and 3. Okay. Now, also listen to what the question is asking for. Okay. The question says determine the coordinates of the turning points. Okay. So you have to then put them in coordinates form. So it has to be a point, like I did here. Right? So you have to put together the two coordinates together to form a point or a location. Are we clear? So from this, I'm not sure how many marks this question contributes, but you'll then get all the marks. All right? Then I'm just going to quickly erase here because this space is reserved for... Actually, I think I can leave this. Let me just erase here. I'm going to need the coordinates because now I'm going to plot the graph 1 over. So let me do this. Just going to erase up here. Then plot these here 1/3, 49/27, close bracket, 1 and 3. There we go. So now we have the turning points. We just have to figure out what the x-intercepts, or yeah, we have the y-intercept also. We're going to take it directly from the equation. It's going to be 0 and 2, right? So what we need is the coordinates of the x-intercepts, right? And remember, a cubic function can have a maximum of 3 x-intercepts, okay, and a minimum of 1 x-intercept. All right, so we don't know what we're going to end up with, but we have to calculate it. So how that works, I use the synthetic division method. Okay, so to find the first number, the first x-intercept, you use trial and error. Okay, so you have to try different possible x values. You do it on your calculator, then whichever one, or the first one to give you an answer of 0, right? That's going to be your first x-intercept that you're going to use in your synthetic division method. Okay, so we're going to quickly do that. I usually just take numbers ranging from -2 to +2. So I'm going to try, let me start with +2. See what positive 2 will give me. I'm now putting it in my calculator. Let's see. There we go. Positive 2 works. So x equals to 2 is going to be my first x-intercept. Okay, I hope that is crystal clear. So then I go to my synthetic division method. I put the 2 outside, right? Then I separate them. Then inside this, I'm going to put all the coefficients as well as the constant of the cubic equation, right? So we're going to look at the x cubed. What's the coefficient of x cubed? Is going to be -1. What's the coefficient of x squared? It's +1. What's the coefficient of x? Is +1. What's the coefficient of 2? Is going to be +2. Okay, then from here I'm gonna, let me just quickly do this. So in here I'm going to put all the remainders, okay, that I'm going to use to formulate my 2 factors of the cubic equation. Okay, so the first factor is going to be a binomial. The second factor is going to be a trinomial. Whatever values I'm going to end up with in here will be the factors that go into the trinomial. Okay, for the binomial, I'm already sorted. I already have the factor. It's the 2 that I'm going to use to multiply here. Okay, so now let's jump into this. Now I opted for this method because it's so much easier than the other ones. Okay, so what we're going to do is, first thing first, you just drop the 1 here, put -1. Then you're going to multiply the -1 with the 2. -1 times the 2, it gives you -2. You take the -2, put it here, right? And just don't forget this, we are adding. Okay, so then you're going to say +1 plus -2, it gives you -1. Then you're going to say the -1 times the 2 is going to give you this -1 times that 2. Okay, it's going to give you -2 again. Then you say +1 plus -2 gives you -1. Then you say the -1, this -1 times that 2 over there is going to give you -2. Now with the synthetic method, the last value, right, or the last difference should be 0. So when you say 2 plus -2 should give you 0. If this is not 0, then it means that you made a mistake in your calculations. Okay, and we don't want that, do we? Because if you make mistakes, you lose marks. Okay, so now clearly everything we've done is correct because our last value is 0. Then we have to formulate the 2 factors of the cubic, which is going to be the binomial. With the binomial, we're going to formulate it using this 2, right? But now it's going to be the opposite sign. So it's going to be a -2 instead of a +2. Why do we say so? It's because remember when I started this question, I said the first x-intercept is 2, right? So it means that x is equal to 2. Now, if I had to reverse this calculation, I would transpose the 2 to the other side, which would then give me x minus 2 equals to 0, right? So when I put it as a binomial, I can't put it as x plus 2. I put it as x minus 2. Why? Because later on, I'm going to have to take that binomial, equate it to 0. So then when I transpose the -2 to the other side, it gives me the +2 that I got when I was using, or when I was doing trial and error in the calculator. I hope that makes sense. So I'm going to have x minus 2 here, right? I'm reversing the calculation. Then I'm going to say open bracket. Now for this, I'm going to use the trinomial. This is going to be the coefficient of x squared. Let me just put everything here. This is going to be -x squared, right? Minus 1x, right? Minus 1. So I take these values that you see, the -1, -1, -1, they become what? The coefficients. And the last one here, this -1, is going to be the constant in the quadratic or in the trinomial. Okay, then I'm going to have my -1 x squared, then -1x minus 1. Then I close this bracket. Okay, And then I equate this to 0 because we are solving for x-intercepts, which means that the y coordinate or the y value is 0. Okay. Then I can equate each one of the brackets to the 0. That's where now this comes into play. Okay. I'm quickly going to erase here. I'm then going to say, okay, the x minus 2 is equal to 0. Therefore, x is equal to 2. Then come to this, minus x squared minus x minus 1 equals to 0. Then I factorize this, goes to 0. It's not possible, actually. It's invalid. Valid. Or you can say no solution. Okay, so you can put it in your calculator in the quadratic formula, can try to find the factors. It's just not possible. Okay, meaning that our graph has only one x-intercept. Okay, so then we're going to come over here, put it there. Our x-intercept is going to be 2 and 0. Then let's plot everything. So we got everything we need, right? We have our turning points, we've got our x-intercept, y-intercept, and I think that's pretty much it. So let's plot everything. So we're going to say the 1. I'm just going to have to extend this here, right? Forgive me and the mess I'm about to cause here. So the 1 goes with the 3. There's the 3 there. Let's put the 2 maybe somewhere here, 2. So that's the 1 and the 3, right? 1 and 3. Then this is where the graph is going to intersect the y-axis, right? And then where's the other turning point? So negative 1 over 3 is over here. But what's 49? 49 over 27. It's 1.8. So 1.8 is going to be slightly below the 2 there. So that's the negative 1 over 3 and 49 over 27. Put it there. Then we just need to plot the x-intercept now of 2 and 0. So we can say 2 and 0 is here. Okay. So then we join everything. So this is how I draw it. So I join the points together, join this with that, join this with that, join this with that. So from this, you can already tell the picture, right? That, oh, it means from the negative 1 over 3 and 49 over 27, it has to go up. There we go. And then from the 2 and 0, which is here, 2 and 0, it has to cut across and go down. And then just like that, you've drawn your graph. Okay. So how many points do you need to draw this graph? You only need these 4 points. Or in a case whereby you have more than one x-intercept, you just need the x-intercepts as well as the turning points and the y-intercept. All right. And remember, this is just a rough sketch. They haven't said that draw the graph up to scale. Okay. They said draw a rough sketch or sketch the following. Okay. So this is your graph. We sketched it using just four points. Yeah. Okay. So I hope that you understand how all that was done. We're now going to move over to the next question. Okay. Question number 3. Okay. I believe this is our last question. So this one shares more information, right? Over and above what we had initially, it offers us more, or it shares more information. It says points E and W are 2 variable points on f prime, meaning on the first derivative, right? And are on the same horizontal line. Okay. H is a tangent to f prime at E. G is a tangent to f prime at W. H and G intersect at D with the following coordinates A and B, right? And as we always do, we have to read this twice, right? Points E and W are 2 variable points on f prime and are on the same horizontal line, okay? Now, what do they mean by the same horizontal line? It means that if E is over here, W would be that side, because they have to be on the same horizontal line. It means that same level, same height. Okay. So they further said H is a tangent to F prime at E, right? Meaning it touches this graph here at E. Let me just do that. It's a tangent at E, right? There we go. And G is a tangent at W. Okay? And then G and H intersect at D, meaning where they cut each other, that's going to be called point D, right? There we go. Then they said, write down the value of A. Okay? Now, here's the interesting thing about this. When tangents touch a parabola at same points, right? At the same points, right? Those two tangents will have the same steepness, but in opposite directions. Let me repeat that. So, when tangents touch a parabola at the same horizontal level or line, right? Like here, E and W, right? They said E and W are on the same horizontal line, and the H touches E, G touches W, right? So the two graphs, G and H, will have the same steepness because they touch 2 points that are at the on the same horizontal line or on the same level. Okay. Now we're gonna try to prove this, so that it's not just something I say, but it's something that you can calculate. All right. So we don't have the coordinates of E and W, so that's going to make it a bit difficult for us to believe. So we're going to take P and Q. Let's say that we have two tangents that cut at P and, is it P? P and Q, right? Yes, P and Q. So we're going to find the first derivative. So remember, the parabola is the F prime. So if we want to calculate the gradient of the parabola, we have to do the first derivative of the parabola or the second derivative of the cubic. So we're going to take the F prime x, we derive it one more time. Okay, x squared, I think it was plus 2x plus 1, if I'm not mistaken. Yes. So then we derive this again. It's going to give us that. Then we have negative 6x plus 2, right? Then we're going to substitute. Okay, let me just maybe say this again, because I don't want to lose you guys. The F prime x is the equation of this parabola, right? Now, if we want to calculate the gradient of a tangent on a parabola, we have to derive the equation of the parabola, okay, which is the quadratic. You have to derive the quadratic. That's why I'm doing this, okay? So then I've derived the equation of the parabola so that I can get the equation of the gradient of a tangent on the parabola, okay? So what we're going to do then, we'll say, okay, let's check the gradient of a tangent on the parabola at negative 1 over 3, right? We're going to put everything here, plus 2, negative 6, open bracket, negative 1 over 3, plus 2, it gives us 4, right? So if a tangent passed here, it would have a gradient of 4, okay? And then let's check, let me do this. Then let's check if a gradient, if a tangent passed at 1, what would be its gradient? 1 plus 2. We put 1 here. It gives us negative 4. You see? So the steepness is the same, but in opposite directions. Okay? Meaning that at E and W as well, we're going to be looking at the same scenario. Do you understand? So the gradient that passes, or the tangent that passes at W and the tangent that passes at E, they share the same steepness, but in opposite directions. Okay? This side is going to be the negative. This side is going to be the positive. right? Obviously, you should know the difference between a positive straight line and a negative straight line, right? So now, if a line moves like this, we say that it has a positive gradient. If it moves that way, it has a negative gradient. That's why you see at 1, the gradient is negative. It's because the straight line will move like this. And at negative 1 over 3, the gradient is a positive. Is because it's going to move like this, okay? Right, now I'm going to quickly erase this because our focus is on E and W, right? So now, from here, we can then say, if these straight lines share the same steepness, right, it means that where they intersect, and remember, they're coming from the same what? They're coming from the same horizontal line, from the same level, right? It means where they intersect at point D, that's going to be the midpoint of E and W, okay? So point D is going to be, let me do this, point D is going to be, the x value of point D is going to be the midpoint of the x coordinate of E to the x coordinate of W. I hope that makes perfect sense. I hope that is crystal clear, okay? So point E and W, the meet at point D horizontally, okay? The x coordinate of E and the x coordinate of W meet at the x coordinate of, their midpoint is the x coordinate of D, okay? So the same thing applies. We can also use the Q and the P, okay? So if E and W meet at the x coordinate of D, P and Q would also meet at the same x coordinate. Because if we draw tangents from P and Q, they would also meet at point D. If you draw them like this, they would also intersect each other at point D because they share the same steepness. Okay? I'm really trying to explain it so that I don't just give you an answer and leave you with a lot of questions, okay? So then what we're going to do from here is, we're then going to say, okay, let's see. So the x coordinate of D, which is the A, just give you a minute. There we go. So we'll say the x coordinate of D, which is the A, we'll say A equals to, we say 1 over 3, right? Let's say 1 over 3. And then we say it's going to be over 2 plus 1. Let's see. It'll be 1 over 3. 1 over 3 plus 1, 2. Then it gives us 1 over 3. Okay? So that's how this is going to work. But calculating the answer is the easy part. The tricky part is understanding why we're doing what we're doing. Okay? So we are doing this because the steepness of the two graphs is the same. Okay, the steepness, yes, it's in opposite directions, but the steepness is the same. Okay, and that's why we say, okay, the x coordinate of D would be the midpoint of the x coordinate of E and W, and it would also be the midpoint of the x coordinate of what? Of P and Q. Okay, I hope that makes perfect sense. So all you have to do is to get the midpoint of P and Q. That's going to be the x coordinate of A. We could have used the x coordinates of E and W, but we don't have them, right? All we know is that they're on the same horizontal line. Okay.